Electric current is one of the most important concepts in physics and in our daily life. Think about it. From fans and lights to mobile chargers and motors, everything works because of electric current. So what is electric current? Electric current is defined as the rate of flow of electric charge through a conductor. In other words, it tells us how much charge passes through a point in a circuit in a certain amount of time. The mathematical formula for current is I equals Q divided by T, where I is the current in amperes, Q is the charge in coulombs, and T is the time in seconds. This means that 1 ampere is equal to 1 coulomb of charge passing through a conductor in 1 second. Now let's talk about the direction of current. There are two ways to describe it. Conventional current flows from the positive terminal to the negative terminal of a battery. This is the direction we use in circuit diagrams. But in reality, electrons move from the negative terminal to the positive terminal. This is called electron flow. For electric current to flow, three conditions must be met. First, there must be a closed circuit because current cannot flow through an incomplete path. Second, there must be a potential difference or voltage to push the charges through the circuit. Voltage is defined as V equals W divided by Q, where W is the work done to move the charge. And third, there must be a conductor, such as a copper wire, that allows electrons to move freely. One of the most important laws in electricity is Ohm's law. According to Ohm's law, voltage equals current multiplied by resistance, or V equals IR, where V is voltage, I is current, and R is resistance. This law is very useful because it helps us understand the relationship between voltage, current, and resistance in any part of a circuit. Electric current can be direct or alternating. Direct current, or DC, flows in one direction only, like in batteries or solar cells. Alternating current, or AC, changes direction rapidly and is used in homes, offices, and industries. Now let's move to the effects of electric current. These are very important because they are the basis of most electrical appliances we use every day. The first effect is the heating effect. When current passes through a conductor, it produces heat. This happens because electrons collide with the atoms of the conductor, producing energy in the form of heat. The heat produced can be calculated using Joule's law, H equals I squared RT, where H is heat, I is current, R is resistance, and T is time. We use this heating effect in electric irons, heaters, bulbs, toasters, and oven coils. The second effect is the magnetic effect. A current-carrying conductor produces a magnetic field around it. This effect was discovered by Hans Christian Ørsted and is the principle behind motors, generators, electromagnets, transformers, relays, and solenoids. To determine the direction of the magnetic field, we use the right-hand thumb rule. If you grip the conductor with your right hand and point your thumb in the direction of current, your fingers will show the direction of the magnetic field. The third effect is the chemical effect. When current passes through a solution or liquid, it causes chemical changes in a process called electrolysis. This effect is used in electroplating, metal purification, battery charging, and the separation of chemical compounds. In electrolysis, the liquid that conducts electricity is called the electrolyte, and the plates dipped into it are called electrodes, with the positive electrode called the anode and the negative electrode called the cathode. In summary, electric current, described by formulas such as I equals Q divided by T, V equals W divided by Q, and V equals IR, plays a crucial role in heating, magnetism, and chemical reactions. It is the backbone of modern electrical technology, and every bulb, motor, charger, and battery works because of these principles. Electric current not only makes our life easier, but it also powers almost all the devices we use daily. Understanding it is essential for anyone who wants to explore the world of electricity and electronics.